Swach Namaskar. I am Mrs. V.SUHASINI, Maths PGT from TSRS and Junior College, BODHAN, Girls at Edapalli, TRE Hyderabad. On this auspicious occasion, I thank Sri CH.CIRCLE Garu, Honorable Secretary, Rice, and Sri C.S. Prasad Sir Garu, Honorable Deputy Secretary Sir, Rice, who guided us to do this work without pressure but with pleasure. I also thank Sri Satish Sir Garu, Principal, TSRS&JC, Sarvel, for guiding Maths Department in doing online classes. I thank all my fellow coordinators, my teachers, my friends, my Maths group members, and all other well-wishers who supported to do this work. The Department of Mathematics welcome all the intermediate students, new joinees, first years and second years to this wonderful webinar session. Today, I am going to present the content, the syllabi of intermediate maths 2B, as well as a small introduction class on the first chapter of 2B, which is circles. Before that, I would like to give some introduction about maths. Is maths great, children? Yes. And about this maths, we have a great sloka in our Sanskrit. Yadhashika mayuranam naghanam maniyotata tatvad vedhanga shastranam dhanitam udhavistikam. This Sanskrit word, if translated, gives the meaning that as the beautiful crown on the head of a peacock, as the diamond on the head of a snake, mathematics shines on the top of all shastras. This shloka gives the importance of mathematics among various sciences. When we see intermediate syllabus of both first year and second year, the headings of chapters fall under 4 important categories. That algebra, coordinate geometry, calculus, and probability, trigonometry. The combination of all these chapters together gives us a great in the field of because of it is a form of calculus. It can bike and engine, and travel in the plane, all depend on applications of calculus. Example, when we travel in a plane, which is created on the principle of aerodynamics, whose concept would contain a calculus. Iron boxes, iron bulbs, every day-to-day life electronic gadgets are applications of calculus. In physics, integration is very much important. For example, to calculate the center of mass, center of gravity, and mass moment of inertia of any vehicle, to calculate the velocity and trajectory of an object, predict the position of planets, we need the applications of calculus. The wheel place the axle in the center of a circle, and with the property all the points on the perimeter are equidistant from the center, you get the smooth ride that requires the least propulsive energy too. A circle is rotationally symmetric. That makes a circle the perfect shape for the core of screw. The circle is that shape which has the largest possible ratio of area to perimeter. Most bottles have a circular horizontal cross section. Any other shape would require more material to contain the same amount of space. From the wheel of a vehicle to the path of an orbit around the path of orbit of a satellite around the celestial bodies are in the paths of circle or ellipse or hyperbola, parabola, and so on. So when you study these chapters, you will get enough knowledge for your higher education, and it serves you better in research areas. We have day-to-day life applications. So the main motto of introducing these chapters in intermediate is to enhance your subject knowledge, and intermediate works as the bridge for your 10th class studies and as well as for your higher studies. So the course intermediate is designed in such a way that it starts from your lower classes knowledge and extends where you can go for your higher education. In the area of research, you will come to know the many applications of both integration and differentiation with calculus along with geometry. AutoCAD is such an example where all the geometric figures are there. So I welcome to the Department of Mathematics to learn such a great subject. So today we will start with our first chapter. And we already know the basic definition of circle in our earlier classes. In our first class, we have also studied what is local. So with these prerequisites, we start our chapter. These are the syllabus of our intermediate. In Match 2B, we have two branches, coordinate geometry and calculus. In coordinate geometry, we have circles, system of circles, parabola, ellipse, hyperbola. In calculus, we have integration, definite integrals, and differential equations. Circles. Today we are going to say definition of the circle, equation of the circle, and related problems. Necessary and sufficient conditions for a general second degree equation to represent the circle and related problems. And some important points. Let us take a plane. In the plane, consider the x-axis and y-axis, both horizontal and vertical lines, and the point of intersection of x-axis and y-axis origin. And this coordinate axis divide the whole plane into the four quadrants. In this plane, let us consider a fixed point. And from this fixed point, let us consider the points which are equidistant. So we are considering the blue points are the points which are equidistant from the point of in pink color, which is in the center. The distance, constant distance is indicated by green lines. Do we have only 8 such points? No, we have infinite points in such a way. Collect all those infinite points. The path of those infinite points is a circle. And the fixed point is called the center of the circle. And what is the equal distance? Is called radius, which is CP in the figure. So here is the definition for you. A circle is a set of points in a plane such that they are equidistant from a fixed point lying in the plane. So whatever the points we are trying, whether it is fixed or collection, it's all about the plane. If the same definition is applied in the space, that gives rise to a geometric figure called sphere. So let us restrict ourselves to topic circles. The fixed point is called the center, and the distance from center to any point of the circle is called radius of the circle. In the figure, points is called the center and CP is its radius. Children, the coordinate geometry is such a beautiful chapter where we combine, or it's a fusion of both geometry and algebra. Here we have an equation, which is the algebraical interpretation of a circle. To define a circle or to draw a circle, the two important things are center and radius. And when we know the center and radius of the circle, we can write the equation. How? X minus h whole square plus y minus k whole square is equal to r square. How can we get this equation? Let us see. For this, you need a little knowledge of locus of our first year chapters. To find the equation of any chapter, what we need is a point on the locus. What is the first point that we know in the question? Center of the circle. And what should be the first thing that we need to do to find the equation? We have to consider a point on the locus. Let Px comma y be a point on the locus. Then, when the point is on the locus, it satisfies some geometric conditions. What is the geometric condition satisfied by this point? Observe the figure, children. Cp is equal to r. Cp is the distance between C and P. As distance formula is root x2 minus x1 whole square plus y2 minus y1 whole square. In order to remove that root, we square on both sides. So the distance between x minus x comma y and h comma k is x minus h whole square plus y minus k whole square is equal to r square is the required equation of the locus of P. I repeat, first we have to take a point on the P and we have to find out the geometric condition satisfied by P and apply the suitable formula and then simplify, which is the required equation of locus of P. And when h comma k is the center, the formula takes x minus h plus y minus k whole square is equal to r square. Now, in place of h comma k, we have 0 comma 0. That is, instead of any other point in the plane, now we have origin as the center of our circle. What is the equation? Instead of x minus h, in place of h, we have to write it as 0. X minus 0 whole square plus y minus k will now y minus 0 whole square. It's equal to r square. X minus 0 is now x square plus y square is equal to r square. So looking at this equation, we'll come to know that h comma k are 0 comma 0. H comma k are 0 comma 0 in the sense it's a circle centered at origin. And this equation, x square plus y square is equal to r square, is called the standard form of the circle. On expanding this equation, we'll get an important note, children. Let us take this note. X minus h whole square plus y minus k whole square is equal to r square should be expanded using the formula a minus b whole square. What is a minus b whole square? A square minus 2ab plus b square. When we expand, we'll get x square term, h square term, 2hx term, y square term, k square term, 2ky term, and r square term. Let us rearrange these terms in standard form of second degree equation. X square term, y square term, x term, y term, constant. Let us take this minus h as g, minus k as f, and the whole constant that we have, h square plus k square minus r square as c. And substitute these values in the above equation. We get x square plus y square plus 2gx plus 2fy plus c equal to 0. And the center of this circle is h comma k. What is h now? Minus g. What is k now? Minus f. So, sorry, h comma k will be now minus g minus f. And radius r will be equal to, from this relation, c is equal to h square plus k square minus r square. Our radius will be equal to under root of g square plus f square minus c. And whatever the value we have inside the root is always greater than or equal to 0. Children, we have studied now two equations. One is x minus h whole square plus y minus k whole square is equal to r square. In this, it is the first circle. On the slide, it is shown as the first circle where h comma k is the center and px comma y be any point on the circumference of the circle and r is the radius of the circle. And this is called the first form of the circle, that is standard equation of the circle. Now, where minus g minus f is the center and r is the radius, px comma y be any point on the circle. Here the value of r is under root g square plus f square minus c. Let us compare both. Can you compare the two circles equations you learned so far? Standard form of the circle and as well as general form of the circle. The equation of the first form is x minus h whole square plus y minus k whole square is equal to r square. What is the equation of general form of the circle? X square term plus x square plus y square plus 2dx plus 2fy plus c is equal to 0. And what is the center of the first circle? H comma k. Here, what is the center of the second circle, children? Minus g minus f. And radius of first kind of circle is r. Here also radius r, but the value of r is under root of g square plus f square minus c should be noted. These are the very, very basic important formulas that you need to work on so that you can start your exercise. Let us solve this problem, children. Find the equation of the circle which is whose center C 2 comma minus 3 and radius 4. First, in the mathematics questions, first we have to write what is given. Given that center of the circle CH comma K is equal to 2 comma minus 3 and radius R is equal to 4. And what is the formula to find out the equation of the circle? First, it is formula should be written. Here in the PPT, formula is not written, but when you present in the exam, you have to write the formula. Even if your calculation is going wrong for formula, you will get a mark. So always formula should be written. X minus h whole square plus y minus k whole square is equal to r square. What is h comma k, children? H is 2 and k is minus 3. We have to be careful when minus symbol comes. So x minus 2 whole square plus y minus of minus 3 will become plus 2 whole square is equal to whole square. Expand this using a minus b whole square and a plus b whole square and rearrange the term as a standard form of the circle. X square term, y square term, x term, y term, constant. Then we'll get x square plus y square minus 4x plus 6y minus 3 is equal to 0 is the required equation of the locus. Let us solve another problem. In the previous problem, we were given the center and radius directly. But in this problem, we know only center, but we don't know the radius. So to find out the radius, a condition is provided. In the side, you observe it is written with the red ink. Find the equation of the circle passing through the origin and having the center at minus 4 comma minus 3. So passing through the origin provides us a condition. What is passing? What is the radius now? When our circle is passing through origin and centered at C, the distance between C and O, that is OC, is the radius. So let us find the distance between the 2 points C and O using the formula root x2 minus x1 whole square plus y2 minus y1 whole square is equal to r square, which is r square is equal to 25. Substitute that value in the formula x minus h whole square plus y minus k whole square is equal to r square. And expanding x plus 4 whole square plus y plus 3 whole square is equal to 25, we get x square plus y square plus 8x plus 6y is equal to 0 is the required equation. Children, here we observe an important thing. Our circle equation x square plus y square plus 8x plus 6y equal to 0 is free from constant. Let us observe an important formula here. In the first year also we come across this kind of equation. Y is equal to mx plus c is the equation of a straight line whose slope is m and having the slope m. So y is equal to mx is a line passing through the origin. Now there we don't have cy intercept. So it's an example to say an important formula that if a curve passes through origin, it will be free from constant. Can you find the difference between y equal to mx plus c and y is equal to mx? Y equal to mx plus c has y-intercept on the y-axis. C is the y-interceptor. Whereas y equal to mx is the line passing through origin in which there is no constant. In the same way, x square plus y square plus 8x plus 6y equal to 0 is free from constant. It explains us the given circle is passing through origin. So to check whether your answer is correct or not, you can have a glance. Let us discuss these points in detail at the end of the class. And children, in the previous slide, we have seen that x square plus y square plus 2dx plus 2fy plus c equal to 0 is the equation of the circle in the standard form. Do all the second degree equation represent a circle? Answer is no. In the first year coordinate geometry, we have discussed a chapter in pair of straight lines. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represents a pair of straight lines following certain conditions like abc plus 2fch minus af square minus bb square minus ch square and some other conditions. So the same second degree equation represents a pair of straight lines or a circle or some other conic depending upon the real coefficients a comma h comma g comma b comma f comma c. So the equation is same, but the coefficients change. When coefficients change, the geometric meaning will differ. To see ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is the equation in pair of straight lines as well as in the circles. But it is not only one, it is a family of equations put together. Like y is equal to mx is a single equation. But given different values for m, we get infinite straight lines passing through origin. Like that, in ax square plus 2hx square plus by square plus 2gx plus 2fy plus c is equal to 0, given different values for the constants a comma h comma g comma b comma f comma c, the real constants, we have this equation represents a circle. If and only if it follows three conditions. What are those? The coefficient of x square must be equal to coefficient of y square, but both should not be equal to 0 at a time. What is the coefficient of x square? A. And coefficient of y square? B. So A should be equal to B, but not is equal to 0. First condition. And the second condition is coefficient of xy is equal to 0. X square coefficient is equal to y square coefficient, but not equal to 0. Second condition is xy coefficient must be 0. That means there should not be a xy term in the circle equation. And the third condition is g square plus f square minus ec is greater than or equal to 0. Sorry, it is wrongly printed as 0, 1 in the PPT. I request all the children to kindly make a note that it is greater than or equal to 0. Note, center of this circle is minus g by a comma minus f by a. And radius is under root of b square plus f square minus ac by a. The proof is simple. If it represents a circle, we have to prove these conditions are true. If these conditions are true, we need to prove it is a circle. First, it represents, let us take it represents a circle. Let alpha comma beta be the center and r be the radius. And we find the equation of the circle using x minus h whole square plus 5 minus k whole square is equal to r square. And the equation that we expanding now, and the given equation ax square plus 2x square plus by square plus 2gx plus 2fy plus c equal to 0 represents the same equation of the same circle. So we compare the equation and we get the three conditions. If these three conditions are imposed on a circle, that will take the form x minus h whole square plus 5 minus k whole square is equal to r square, hence represent a circle. From that equation, we can easily find that minus g by a comma minus f by a will be the center and root g square plus f square minus ac by a will be the radius. Let us solve a problem related to this, which may come in the 2-mark question in IIB. Find the values of a comma b if the equation ax square plus bxy plus 3y square minus 5x plus 2y minus 3 equal to 0 represents a circle. First, given equation. Whatever the given data is there, read the question. First is read the question and write the given data. For that also you can have a mark. Given equation ax square plus bxy plus 3y square minus 5x plus 2y minus 3 equal to 0 represents a circle. When it represents a circle, it must follow three important conditions. What is the first condition? Coefficient of x square is equal to coefficient of y square but not equal to 0. So coefficient of x square is equal to coefficient of y square. In the given question, coefficient of x square is a and coefficient of y square is 3. Therefore, a is equal to 3. There we got one value. And what is the second condition? Coefficient of xy is 0. What is the coefficient of xy, children? B. And b should be equal to 0. Therefore, the two values we got now, a is 3 and b is equal to 0. And substituting these values in the given equation. Now we don't have xy term as the coefficient of xy is 0. Now we have 3x square, 3y square minus 5x plus 2y minus 3 equal to 0. Children, always coefficient of x square and coefficient of y square are same. Hence, dividing the equation with that coefficient, we get the standard form. So it is easy for us to calculate the center and radius always. So we always make sure that coefficient of x square and coefficient of y square as 1. Though it is other number 3, what did we do here? We divided the equation with number 3. So dividing the equation with 3, we got the g value as minus 5 by 6 because 2g is minus 5 by 3. Therefore, g is minus 5 by 6. And comparing it standard form, what is y coefficient, children? 2f is equal to 2 by 3, from which f is equal to 1 by 3. And the constant 3 by 3. First we have 3 and then we are dividing the whole equation again by 3. Hence the coefficient is 1, which is c with minus symbol. So c is equal to minus 1. That's all. When we need to find the radius, just substitute root over g square plus f square minus c is the formula. And g square, though we have minus, when we square it will become positive. Same for c, f, g. And what is the answer? Root 65 by 6. Now, other important question that may fall under our very short answers is that we have an equation which represents a circle. One of the value is not given, like g, f, c are the 3 unknowns in the circle. The value of c is not given, but a condition is provided to find the value of c. What is the condition? If this equation represents a circle with radius 6, then find the value of c. Just write the given equation. And he is talking about the radius. So let us write the formula of radius under root g square minus c is equal to 6. And substitute the values of g, f, c. Before that, you need to read the values of g, f, c from the question. So g is 2. When square it is 4. F is 3. And when we square it is 9. And constant c. Squaring on both sides. And on simplification, we get c is equal to minus 23. And if g square plus f square minus c is equal to 0, that is, radius of the circle is 0, then this represents a point circle. Now, no more it will be like a big circle. It is like a dot. In this case, the center itself is the point. Okay, what is the dot then? It is nothing but the center. And the equation of the point circle having the center at origin is x square plus y square is equal to 0 square, which is x square plus y square equal to 0. I talk about this equation again. The center's origin, radius is 0. Substitute in x minus h whole square plus y minus k whole square equal to r square. H comma k are 0 comma 0. Radius is also 0. So it is the special circle whose center is origin and radius is 0. And what is observe? The equation of the circle passing through 0, 0 will be in the form x square plus y square plus 2gx plus 2fy is equal to 0 represents a circle which is origin. Observe figure, children. Is our circle passing through origin? Yes. Then it is free from constant. Equation of the circle whose center is on x-axis. Look at the circle. Where is it? It is placed in such a way that the center of the circle is on x-axis. When the center is on x-axis, what is the center? Minus g comma minus f. If that is placed on x-axis, f will be 0. That is, y coordinate of the center is 0. When f is 0 in the equation, it is x square plus y square plus 2gx plus c equal to 0. Children, if this center is on x-axis and passing through origin, what could be the equation? I repeat, the same circle whose center is on x-axis and passing through origin will be more simple. X square plus y square plus 2gx is equal to 0. Like that, I have to apply the different conditions on the given equation. Same as that, we have another equation. This time, the center of the circle is on y-axis. When it is on y-axis, x coordinate of the center, that is minus g, will be 0. Substitute the value of g as 0 in the given equation, standard form of the circle. we get x square plus y square plus 2fy plus c is equal to 0 as the equation of the circle. If this circle passes through origin, what will be its equation, children? X square plus y square plus 2fy is equal to 0. And we have concentric circles. Children, when you see still what, when you draw a pebble or a stone, anything, the ripples form. And what, in which shape the ripples form? Concentric circles. What are concentric circles? Two or more circles are said to be concentric if their centers are same. And how can we write the concentric circles? If the concept is similar to the equations of parallel lines. If we know one line, x plus by plus c equal to 0. How can you get the equations of different lines parallel to the given line? Ax plus by. Instead of c, we'll write plus k equal to 0. In the same way, if you know the equation of one circle out of all these concentric circles, then any other circle which is concentric with a given circle can be written as x square plus y square plus 2gx plus 2fy. Instead of 3, now we have to write k is equal to 0. That is, by just for different values of constant, we get different circles in the family of concentric circles. So this is the brief introduction of our circles. Here, one important point is unit circle. This unit circle, any circle whose radius is 1 is called as unit circle. So its equation will be x minus h whole square plus y minus k whole square is equal to 1 square. Thank you, children. With this, we end our Match 2B introduction class for today. Work on our exercise 1A and solve the problems you can. Thank you all. Sir.